Okay, here's an overview of the motorized Walter tilting turntable that I added a stepper motor rotator to. I just wanted to go over some of the features so you know what you're getting. So it's a Walter RTS-500G. The table's 19.5 inches across, or 500 millimeters, T-slotted, and you can tell that the surface is above all of the mechanics, so you can put something big on the table and not hit anything. So the tilting mechanism in this guy I left manual is this hand crank here, that when you rotate, you can see it, start to tilt up. Honestly, if you buy this, what you should do, measure this square and get a socket to it and use your drill gun so you're not burning your elbow out tilting this thing if you're going to be tilting and detilting a lot. I don't know what the range is. I'll look at the manual. I don't want to tip it up all the way right now because I might tip over. Yep, you can lower it back down. It's got a 0 stop in the back, so on your way back down, it'll stop back to 0. I mean, it was intended for milling machines, so there's a lot of repeatability built in. And like vernier scales on the tilt, as with the RPM. And then, you've got your table lock here with an adjustable zero finder. Yeah, I mean, it's intended for a piece of machining equipment. So for welding, it's definitely overbuilt, which is good. That's why I like it. So it's a NEMA 34 stepper motor on a toothed timing belt to the drive mechanism. The NEMA motor is being driven by this digital stepper motor controller. The numbers are unitless. You have to do the math to figure out what number of what means what RPM. So the rotation of the motor can be controlled by hand by hitting these buttons here. Or I've got it rigged up such that you can tap the foot pedals for left, stop, right, stop. On the foot pedal, I put this metal divider up the middle. So when you're hitting it with your foot, you can easily reference one side or the other and know where you're at, rather than fumbling all over the place and not knowing what pedal you're gonna hit. Especially important when you got a welding mask. Quick safety thing. This timing belt pulley pinch point definitely needs a machine guard. I'll sheet metal something up before I send it out. On the back side of the toothed timing belt sprocket, I left the gap access to the square drive because you can fit a 9/16 wrench in there and do just fine tuning. If you can see that in the video. Yeah, that's a nice feature. Okay, max and min RPM, I don't know right now. I'll show some text over the video to show what the max and min RPM is. But you can see you can start the rotation, and then with the dial, slow it down. I mean, you can slow it down to a crawl. So it's geared down 120 to 1. So that rotation would be 120 times slower over here on the table. I mean, maybe you can barely see it crawling. I'll do the math and post what the max and min RPM is, but you can also get it going pretty fast. The controller has acceleration and deceleration features on it. I'll include the manual for the controller so you know how to change those settings. But if you listen, you can hear it ramp up to speed. And then when you stop, it'll slow down. Which is nice, so it's not like herky-jerky stops and starts. So this is a 4-wire stepper motor, and I've got the wires on a D9 connector. The pairs are 9 and 8 and then 7 and 6 on this D9 connector. So it's a stepper motor. You could drive this thing with an Arduino CNC Gerbil type controller if you wanted to. I don't know what you'd be doing, but yeah, you could have a CNC 4th axis. You'd have to compensate for any type of back slop if you're reversing directions, which I haven't calculated, but Mach 3 does that. I think Mach 3 and 4 do that super easily. Yep, there you go. So it's a stepper motor. You could turn this into a CNC. So I haven't measured max torque. It's a lot. I mean, it's geared down 120 to 1 on a NEMA 34 motor. You can back calc the math out of the torque curves on the NEMA motor and maybe apply like a, I don't know, an 80% efficiency or something like that. It's a lot of torque. So if you're familiar with how these worm drive tables work, there's a worm screw going here from your drive shaft, and then a sprocket gear, whatever you want to call it, on the table itself. But you can actually pivot that worm gear out of the way to let the table freewheel. Let me show you how to do that. So if you rotate this adjustment dealy-do, it'll bring that worm screw out of engagement and freewheel the table. So if you spin this guy, it's about there. You can see the table freewheel. So I went ahead and tilted it up to like, I don't know, 80 degrees or something like that, just so you can see how I mounted the plate for the stepper motor. Those aren't bolts. They're actually studs that I Loctited into the tap holes into the frame. That way, when you take these nuts off, you still have the locating pins to get back into the holes, which is super nice. If the belt loosens up, I mean, maybe one day you might have to slot these holes, but honestly, like, there's not a whole lot of torque or tension on this belt, so I don't expect it to be a problem. I just wanted to explain this feature down here, because they're not bolts, they're nuts on studs. It's mounted and will ship with these super stout, solid steel base blocks. Don't know what they're for, but they'll be yours. All right, there you have it. A turntable with a stepper motor controller and a foot pedal activation switch. You don't have to use the foot pedal, you can use the hand buttons. Yeah, tap once to go, tap once to stop, other pedal goes the other way. Oh, the forward and reverse have different speed set points, which is actually really useful for jogging in between tacks. Yeah, so there you go. There's a turntable with the stepper motor. Have a good day.